Hey folks, welcome back to another video. Today we're going to walk through add two numbers, the most famous linked list problem on LeetCode. Let's get into it. Alright, so once again the problem description is pretty simple. We're given two numbers whose digits are in reverse order and stored in linked lists. We're told to return the sum of the two numbers where the sum's digits are also reversed and stored in a linked list. So right off the bat, you should notice that the fact that these digits are stored in reverse order means that they've greatly simplified our task. The fact that the digits are stored in reverse order means we can just iterate left to right in the linked list and just add each number from there. This is conceptually a pretty easy problem, but the challenge here lies in the implementation. Let's take a look. In the happy case, both lists have the same length and all individual sums of digits are less than 10, right? We could have a simple loop like so. We initialize an empty node and set both curhead and result to that empty node. I'll explain why in a minute. While L1 and L2 are not none, we set the next node to curhead to the result of adding these two numbers together. We reset the curhead pointer to point to the new node that we just added, and then we set L1 and L2 to the next node to be added. On the next loop, we once again add a new node with the sum of 3 and 6, we set curhead to the most recent node, and we move L1 and L2 to the next node. And then going through all the steps again one more time, we end up with a new node, 6, at the end. And then we can return result.next, which is going to be this yellow boxed area right here. So you might think that this empty node in the front is kind of useless, and you're partially right. The reason we have it is so we can gracefully handle both the first and every iteration after the first iteration. See, if we didn't have this empty node here, we'd have to do this instead. We'd have to initialize our result and curhead to a none value at first, and on the first iteration, we'd have to initialize them if they're none, or otherwise append to an existing result. By having the empty initial node, we can handle the first iteration and every iteration after the first in the same way and reduce our lines of code. But of course, there's a little trickiness to this problem. Let's deal with the simpler one first. Let's say that both linked lists still have the same length, but at least one of the digit sums is greater than 10. Well, given the rules of addition, we'll have to carry over a 1 to the next digit. Again, let's do this gracefully. We'll initialize a carry variable that begins as 0. Then, when we get to the current sum, we add carry to the result of L1.val plus L2.val. When we set the value of the new node, we don't use total, but total mod 10, and then we reset carry to total floor divided by 10. As with all things, things are clearer with an example. So let's continue the code flow with the diagram on the left, starting from the second node. After adding 2 and 4, carry is still set to 0 because 2 plus 4 is less than 10. So total will be equal to 5 plus 6 plus 0. We set the next node to be total mod 10, which is going to be 1. And then we set the carry to carry floor 10, which is 11 floor 10, which is 1. So carry will be equal to 1, which makes sense since we want to carry the tens place to the next digit. On the next iteration, we'll add this carry of 1 to 1 plus 5. This is a total of 7, and we'll set the new node to 7 mod 10, which is just 7. Carry will be set to 0 since 7 floor 10 is 0, and then this is our final result. Alrighty, so we've made a lot of progress, but unfortunately we still have a few more edge cases to consider. Let's now say that the lists are of uneven length. What should we do in this case? Well, the first change we'll make is that we'll keep iterating as long as either of the lists is non-null. So we'll make this an OR instead of an AND. Then when we're calculating our total, we'll only add L1.val if L1 is not none. We'll also only add L2.val if L2 is not none. Everything else here is the same. I'm not going to walk through this in a diagram since it should be pretty self-explanatory. Now, finally, we have one more edge case to consider. What happens when this node is changed to 9? Well, 9 plus 5 is 14, so we'll have a carry of 1. When we add 1 to the 9 here on the end, we'll end up with 10. So once again, we'll have a carry of 1, and we'll add a new node with value 0. So here we've already run out of L1 and L2 nodes, but we still have a carry of 1 to add to our result. So the final result should end up looking like this. Luckily, to handle this case, we just need to add 2 more lines of code. At the end of our loop, we just need to check if the carry is larger than 0. If so, we create one more node with list node carry. This problem is mostly an implementation challenge, not so much a conceptual challenge. If you got a working solution, but your code is really sloppy or really long, I'd suggest working hard to simplifying the code until it looks something like this, since clean code will actually matter a lot in an interview, and this is the most famous linked list problem on LeetCode, so it's probably worth getting this down now. Alrighty, so that's pretty much all there is to this problem, and this is how you handle all the edge cases gracefully. I'll see you in the next video.